Assalamualaikum warahmatullahi wabarakatuh. I'm AMIRA FITHRIYAANI and my other teammates Mohamed SYAHMI, Mohamed ZAFRAN, SAIFUL ADLI, UWAIS NADZMI and NUVIN NADARAJAH will explain the experiment about kinematic viscosity under subject BMMM4623 oil and wear debris analysis. So, kinematic viscosity is the ratio of dynamic viscosity over the density. Oil viscosity depends on temperature, shear rate and pressure. When temperature increase, viscosity will decrease. Viscosity at the operating temperature influence the lubricant film thickness spreading to surface. Objective of this experiment, which is to define viscosity index of oil and to analyze SAE grade of oil. That's all from me. Let me pass to the next presenter. Thank you.
My name is SAIFUL bin MOHAMED, metric P0920102009. So I would like to talk about the methodology. First one, the kinematic viscosity of a fluid is a measure of its resistance to flow under the influence of gravity. It describes the fluid's ability to flow and it's typically expressed in units such as centistokes or square meter per second. Second, the viscosity index is a numerical value that characterizes how the viscosity of a lubricating oil changes with temperature. It provides information about the oil's resistance to tightening at high temperature and tightening at low temperature. The higher the viscosity index, the smaller the change in viscosity with temperature.
Moving on in methodology process, the value of L and H was determined based on ASTM D2270 standard. This is where this standard is used to determine all the L and H value based on the calculation of the viscosity index. Next, it is important to note that the viscosity index method provides an estimation of the kinematic viscosity at a specific temperature based on the oil's viscosity index. It assumes that the viscosity temperature relationship of the oil follows a particular trend. However, this method may not be as accurate as direct viscosity measurements at specific temperature using a viscometer. So, as a conclusion, in this methodology, we can say viscometer can have a more accurate reading rather than using the estimation of kinematic viscosity at certain temperature. Thank you.
Assalamualaikum. My name is NADZMI bin Muhammad NADZMI. My metric number is B0920102090. And in this presentation, I'll be explaining the result that we obtained from the case study experiment. First, we will be conducting an experiment for two samples, which is sample A and sample B. For the sample A, we'll be taking the kinematic viscosity at 40 degrees Celsius. For the first take, the value that we gain is 115.9 and the second take is 111.1, and same for the third take, which is 111.1. From this value, we will get the average kinematic viscosity at 40 degrees Celsius, which is at 112.7. For the sample A, kinematic viscosity at 100 degrees Celsius, we also gain three values, which is 12.5 for the first take, 12.2 for the second take, and 12.2 for the third take. And the average kinematic viscosity at 100 degrees Celsius is 12.3. From this, when referring to the table ASTM D2270 standard table, we'll be using the kinematic viscosity at 100 degrees Celsius, which is 12.3, and we will gain the value for L and H, which is for L is 210.7. For H, we got the value of 112.0. So when using the formula for viscosity index, which is L minus U over L minus H times 100, we will gain the viscosity for sample A, which is 99.291. Same steps will be taken for the sample B, which is the kinematic viscosity at 40 degrees Celsius. The first take will be 156.5 and the second take will be 153.6, and the third take will be 152.5. And the average kinematic viscosity at 40 degrees Celsius is 154.2. The kinematic viscosity at 100 degrees Celsius for sample B, the first take we gain is 50.4, and the second take we gain 50.2, and the third take we gain 15.3. So the average kinematic viscosity at 100 degrees Celsius will be 15.3. From the data that we obtained on sample B, referring to the table ASTM D2270 standard table, the kinematic viscosity at 100 degrees Celsius for 15.3, we gain the value L 306.9 and the value of H 154.1. From the data that we obtained after referring to the table, we can put all the values into the formula for viscosity index. The viscosity index for the sample B, which is 100.065. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad ZAFRAN ARIFIN BEDU ARIFIN. Today I will discuss about the discussion of kinematic viscosity based on the lab that we have done before. So for the discussion, the kinematic viscosity at 100 degrees Celsius is used to determine the grade of the sample oils. The SAE J300 table is then utilized since it lists the allowable range for viscosity grades. According to the chart, the viscosity with a range of 12.5 to 16.3 CST is rated 40. Sample A is more likely to be rated as SAE 30 since its kinematic viscosity at 100 degrees Celsius range from 9.3 to 12.5 CST. Sample B is rated SAE 40 due to the range of 12.5 and 16.3 CST. That's all from me. Thank you.
In the conclusion, viscosity grade and viscosity index are two important factors to take into account while choosing lubricating oil. The viscosity grade helps determine the thickness of the oil and a specific temperature, whereas the viscosity index demonstrates its ability to maintain viscosity stability over a large temperature range. Both qualities must exist in order to select the appropriate oil for the optimum lubrication and protection in each application. Additionally, the viscosity index was determined as a way to gauge how resistant the fluid was to temperature-related variation in viscosity. Understanding these characteristics is essential for choosing the right lubricant for diverse applications such as automotive, as industrial machinery, where temperature fluctuation can dramatically affect fluid performance. The viscosity index offers useful data on the stability and efficiency of lubricant over a many different operational circumstances. The fluid is less sensitive to variation in viscosity brought on by temperature change, the higher the viscosity index.